Welcome to the video tutorial for the GDS automated oedometer system. During this video you will not only learn how to set up the GDS automated oedometer system and a MAR digital displacement transducer, you'll also learn how to use GDSLab to set up multiple stages, to create custom time files to import into GDSLab, and how to import that created data file after all testing has been completed into Microsoft Excel for analysis. Before we begin using GDSLab, make sure that the GDS Automated Oedometer System, or AOS for short, is correctly connected to the PC, with all cables firmly connected in their correct ports and the machine is powered on, ready to be used. Also make sure that the MAR displacement transducer is correctly connected to the AOS with the brackets supplied and connected to the PC with the supplied USB cable and turned on. Now that the GDSAOS system is correctly connected to your PC and powered on, we are ready to start using GDSLab. Make sure that GDSLab has been correctly installed from the CD provided or downloaded from our website. Make sure that your hasp key is installed in one of the USB ports of your PC you will be using, otherwise you'll be unable to access any of the modules purchased. Make sure that your initialization files that would have been supplied with your system are copied over to the correct folder. This can be found in your C drive and in GDSLab folder. As you can see here, I have two initialization files currently in my folder: GDS OEDCalc MAR Station 1 and GDS AOS OEDCalc MAR Station 2. Once this has all been completed, you can then open GDSLab. This is the screen that you will originally see for the first time opening GDSLab. As you can see here, we will now click on the blank page to begin. So we're going to create our first station, which will be the GDS AOS OEDCalc MAR Station 1. If you see no files here at the moment, please make sure that your initialization files have been correctly copied over to your GDSLab folder. Knowing as well that I'm only ever going to use this station in this section, I'm also going to select always start with this file. If you proceed to the object display within GDSLab, you'll then be able to see our system, which is a oedometer frame and a MAR displacement transducer. We firstly have to make sure that all of them are connected to the PC correctly. If you left click on the picture for the oedometer frame, it will then ask you to select the device. As you can see here, I have one device currently connected to the PC, and I can select that from the drop down box. Please make sure that you connect the correct serial numbered GDSAOS frame to the correct station. As you can see here, the serial number of the AOS frame connected to the PC at the moment is serial number 16779. Once it is connected, it will show me the connected serial number here. I'm also going to make sure that my MAR displacement transducer is also connected correctly. I'm going to left click on the picture for the MAR displacement transducer, and then I can select my device. The same applies. Please select the correct serial number for your MAR displacement transducer for each of your correct stations. Once these have both been connected, we can then make sure they are connected correctly and reading within GDSLab. If you select the read button, this will send out a signal from the software asking for the value that is currently being read on each of the transducers. If you get an error message, click read twice. If this does not solve the problem, check the connections to the devices via the PC. So as you can see at the moment, I have a load, a displacement, and another displacement. I just want to check the continuity of my devices and make sure they are connected correctly, so I'm going to apply with my hand a small load to the displacement, to the transducer. And as you can see here, it is reading in the correct direction. I'm also going to do the same with the MAR displacement transducer. You also then have the options of viewing the transducer value, controlling the machines, or you can view both. So you can now see that I have two controlling parameters, the load and the displacement. You can also see that the unit for each of the values is now correct. You will not have to change any of the values within the advanced or calibration tabs for each of the transducers, as these are all stored internally on the firmware. Once this has been completed and you know all of your transducers are reading correctly, we are ready to start setting up the station. The first stage in setting up your test is to select the data save options. To do this, click on the little picture of the floppy disk with data save written underneath. Then you need to select choose data file. You then have the option of selecting the data saving type and the data saving interval. There are four options for the data saving type: linear, which saves a data point every X amount of seconds; square root, which saves a data point every 10 times data point number squared; log, which saves a data point every 10 times the exponential of your data saver; or a custom time file. The custom time file will come back later into showing how to create one, but for the moment I'm going to load one of these. I'm going to browse, and I'm going to select one called OED times. Once I've done this, I can then select next. I then need to select where I'd like my data to be saved. I can choose the name of my file, my type of my file, my drive, and therefore the folder as well. Once I have done this, I can select OK. As you can now see, the data save symbol has a tick showing I've filled all the required data into that section. You may also notice that my section for my sample has now highlighted, allowing me to select it. As I'm testing using an oedometer system, I need to select the British Standard 1377 oedometer. If you do not select this, the correct test will not be shown. When ready, select Set up Sample Details. It will ask me to confirm if it is a test on a new specimen, and to confirm if the specimen is docked or not. This section then allows me to fill in all the required data and all the information I may have about my sample. The information on the left is not always required by GDS Lab, but is extremely useful to have in the data file so that you know all your information for the samples is saved in one location. The initial height and initial diameter of the sample are the most important. These must be correct to your test. I know the height of my sample is 20 millimeters and the diameter of my sample is 63.5 millimeters. Once I've input all my data, I can select OK. Again, you can see that my sample section now has a tick showing I've filled all the relevant data required, and my Add Test box has now become highlighted. I then have the GDS Oedometer logging module. I can select this and I can then select Create New Test Stage. I then have two types of tests that I can perform: oedometer logging or oedometer swelling. I'm going to start by running an oedometer logging test. As you can see, it shows me my current displacement. This is the displacement that is shown on my MAR displacement transducer, not the value that is shown on the AOS frame. I can then select the number of stages I wish to perform, and I can select the stress levels that I wish to have. Once I've filled in all the required data, I can select Next. You then have an optional test start condition, whereas it will set the displacement transducer to 0. As this is a test on a brand new sample, I'm going to select it to start from 0 when the test commences. You also have optional termination conditions. You have an option at which you can end a stage after a certain amount of minutes. You can also do it when T90 has been detected. I'm going to select it that each of my stages ends after 2 minutes. Once I've completed this, I can add my test to plan. As you can now see, I've created a test and my test list has now become highlighted. If I select this, it will show me at the moment I have one stage, the status is idle as I have not begun, and my type is oedometer logging. I also then have the option to change my save interval or my time base. Before I begin my test, I'm going to start by adding my second station. To create the second station, start by selecting File and then Add New Station. Like we did with Station 1, select the blank page and click Create Station. This time, however, instead of selecting GDSAOS OEDCalc MAR Station 1, we are going to select GDSAOS OEDCalc MAR Station 2. Again, I know we would always be starting with these two files, and therefore I wish to select Always Start with this file and click OK. You can now see the station has been filled and Station 2's test plan has appeared. We'll go back to the management display, and here you can now see not only do we have Station 1, we also have Station 2. Like before, select the serial numbers for the devices in the station and make sure that they are reading correctly. As the same with Station 1, we'll start by creating a data save. This time I shall do a linear. After adding all the test details as you have done with Station 1 previously, you can now start running the tests. We'll start with Station 1. If you select the test list, I'm just going to move them about. If you select the test list, you can see Stage 1 is still idle. If you select Go to Test, it will then bring up the test display. In here you have an option of 3 graphs and a data option. You can select 2 y-axis parameters and 1 x-axis parameter per graph. To do this, click on the Browse Live Data options. You have 2 different parameters now. You have the raw data from the test and the calculated parameters from the test. You also have the graph options. Using the drop-down boxes, you can select the different parameters that you wish to display on each of the graphs. I'm going to leave these as they are at the moment, with the time since start of the test and the axial displacement on one graph, the axial stress on another, and the axial displacement 2 on the final graph. However, by By selecting the drop down box, I can then use this and find the parameter I wish to display. Once you've selected all your parameters you wish to display both for the graph and the live test data options, select OK. You can now see my graphs are labelled with the parameters that will be displayed. You can also see for the live test data the parameters at which I selected are also displayed. As soon as you're ready to start your test, click Start Test. While that test is running, you can continue to build other levels and other plans into your second station, and you can also start your second test. These stations can be run independently of each other and do not affect each other in any way. If you ever want to end your test or go to the next stage, you can either pause your test or click the next stage button. If at any point you need to get back to your test plan to create further stages, click on this button here and it will bring back up your test plan window. From here you can add other stations, you can add other stages such as another oedometer logging stage or a swelling stage while your test is running. If you want to go back to your test display window, click Go to Test.
We're now going to learn how to create a custom time file to be used within GDS Lab. To start, you can use two different programs, one being Microsoft Excel and the other being Notepad. The end result is to create a .csv file with your data save intervals created and stored within. We'll start by using Microsoft Excel. Do this by entering all the values only within column A. I'm going to use a data save interval of every 5 seconds . Once I've entered all my values, I then need to save the file as a CSV. So save as. Save. Once it has been saved, this can then be put into GDS Lab to be used as your data save interval. You can also use Notepad. If you open up Notepad, again, enter your time saves. Open up Notepad and again, enter the values you wish to have for your data save interval. This time though, every value must be on its own line. If not, GDS Lab will not pick it up properly. When you've entered all your values, again, save the Notepad and again, save it as a .csv file. And here we have both of our custom time files saved. And that is how you create a custom time file to use within GDS Lab. We're now going to go through how to import .gds files and therefore your test data into Microsoft Excel to be analysed. Start by opening up Microsoft Excel. You're going to want to open your file. Make sure you're on your correct folder where your data has been saved and that you have all files to be searched selected. Find your file and click Open. We are using a delimited type for data. Go next. With a delimiter as a comma. Click Next. The column data format is general. And click Finish. And now we have our data readily available in Microsoft Excel to be analysed correctly. As you can see, all the information has been neatly divided into its correct columns with descriptions at the top. This then allows for easy analysis of all your data that has been saved by GDS Lab. It can also easily be saved as an Excel spreadsheet as well as